Let's take a look at evaluating and interpreting data. When you're reading research articles, this is usually the trickiest part, especially for those of us who aren't very mathematically inclined. But after a while, you'll notice that regardless of the topic or field of research that you're looking at, they all use similar types of methods and they present their data in similar ways. So recognizing some of those patterns is the first step of being able to effectively interpret data and then evaluate it. This is a helpful skill not only for analyzing sources, but also for your individual research projects that will be coming up after you turn in the short research essay. So you might want to be thinking in the back of your mind, what kind of methods and data do I want to use in my own research project? First, there's often more than one way to interpret data. So two different researchers could be looking at the same exact information, but interpret it in completely different ways. That's why it can be helpful to get feedback from someone else on the data you collect and see what conclusions they reach from looking at it. You can avoid some of this ambiguity by carefully designing your methods to account for different variables. We'll talk about that in a little more detail later on. Interpretation of data is essentially an argument where you describe your theory of what you think the data means and what the implications are. And the theoretical perfect study would have such clear results that they couldn't be disputed, so everybody would look at the data and see the exact same thing. But obviously we live in an imperfect and complicated world, so research usually does not turn out that way. You might be familiar with the story of the blind people touching an elephant and describing what they're feeling in all these different ways. So one of them touches the ears and says it's a fan, and another one touches the tusk and thinks it's a spear. Or if you touch the nose, you think it's a snake, right? So with their limited perspective, they're describing what they're experiencing in the best way that they can. But none of them are able to see the big picture. And essentially they're all incorrect, even if their observations are valid. And that's a lot like how research is. The world is very complicated and we all have limited, human minds, and we can't possibly understand everything that's going on, but we do the best we can. And at best, we can focus on a small part of the bigger picture and describe that in as much detail with as much thorough observation as we can. And then putting that in the greater context of other research helps us gain a more accurate understanding of a topic. So one important thing you'll want to consider when evaluating research and coming up with your own studies are different variables that can affect the outcome. Variables come into play in your sample environment and in other ways. So in the sample, if your study involves people, if your subjects are people, then you'll want to take into account things like age, gender, culture, and so on. Typically, it's best to have a more diverse group in your sample, but it also depends on the topic being studied. So just say an article focuses on the prevalence of a certain type of disease within a certain age group or within a gender or a specific group of people, then in that case it wouldn't be considered a flaw if there's only one group represented in the sample. So basically you'll want to go back to the research question and see if the sample appropriately reflects what the researcher is hoping to answer. And then there's the environment or setting. So this includes things like the time of day, noise level, historical context, and so on. For example, if you wanted to try out some kind of new method that you developed for teaching, people a certain skill, you'd probably want to make sure that The study takes place in a quiet environment, so there aren't distractions. Historical context is also something you'll want to consider, especially when evaluating sources. So what was the year when the article was published, and could some of the viewpoints expressed have something to do with maybe historical events that were happening at the time, or maybe a lack of knowledge at that time compared to a more recent study? So that's just a few examples of variables that might come up, but there are many, many variables to consider depending on the topic and the article you're evaluating or the study you are developing. All right, so we talked about qualitative and quantitative data before. So when you're interpreting qualitative data, this is anything based on open-ended information such as from interviews, documents or photos, behavioral observations, and so on. This type of data, because there's not a quantitative element to it, can be very open to different interpretations. So it can be helpful to consider various perspectives. For example, if you're doing, just say, a behavioral observation on autistic children, you can interpret the observations you gather from different psychological perspectives. So there's, for example, behaviorism, there's cognitivism, and different, psychological theories that you could kind of interpret your results through one of those perspectives. So depending on the field, there are usually different theories that could be used to describe an event. So interpreting qualitative data is kind of like solving a murder mystery in a sense, because you gather all these different clues that might seem unrelated to each other, but you put them together and construct a sort of coherent pattern or story that explains what is going on. Now, for quantitative data interpretation, if you're evaluating a source, this is more straightforward in a sense. So did the researcher add up their numbers correctly, or did you notice any flaws or inconsistencies in the data that they present? And typically quantitative data will involve a visual element, so like a chart or a graph, and you can critique that as well. And then another thing to consider with quantitative data is, do you agree with the researcher's stated implications? So just say they found that 2% of the population at any given time is infected with COVID, and they state that this is a major problem because, and they give their reasons for that. So do you agree with that, or do you think they are overstating their case? So that's the type of analysis you will do with quantitative data. And then as far as organizing and presenting your own data, so this would be like for your research projects if you decide to use a quantitative method. There are several different ways to organize and present that information in a way that is helpful and easy to understand. And for most projects, thankfully, all you need is a little bit of basic mathematical concepts to be able to do this. So for example, when you're presenting your data, mean, mode, and standard deviation are very helpful in pointing out what is the most important. So the mean is also called the average, where you add a group of numbers together and then divide by the amount of numbers to see what the average sum would be. For example, this is very helpful to me when I look at people's grades. When I see the average score on a particular assignment, it gives me an idea of how difficult that assignment was and whether I ought to tone it down or make it a little more challenging maybe. And then with mode, you find the value that occurs most often in a set of numbers. This can be extremely helpful as well to see what the most common response to something is. And then standard deviation is basically how spread out the numbers are. And this can be helpful in gaining an overall picture of the data that you collected. Standard deviation is something that maybe not all of us are familiar with. So the basic steps are there. So you find the mean, subtract the mean from each number in the data set, and square the results. Find the mean again for those squared numbers, and finally find the square root of that. And if that sounds extremely confusing, don't worry, I will put this as a separate document in course materials that will take you through each step in case you want to present your data this way. This is an example of what standard deviation looks like when you turn it into a chart. If you have a small standard deviation, then most of the results are closer to the mean or the average. And then a large standard deviation has more of a variety. Standard deviation is often shown as a bell chart. So for things like exam results, SAT tests, and also in health, you'll see this as like a BMI chart. We'll use standard deviation to show what is average, what is unusual in the population. Another way to visualize this is as a plot graph, where the line represents the mean and then the little blue dots show how close the collected data is to the average. And then every once in a while you have something like these dots way up here on top or at the bottom, and these are called outliers that are farther away from the mean or the average than most of the other data. Sometimes an outlier is significant, sometimes not, but you'll always want to look at that if you end up with a result like that to see what that means and what the explanation might be. But in any case, so standard deviation can be represented visually in several different ways and can be very helpful for interpreting information and showing your results to others.